The second couple of problems in this video series is a little bit harder than the first group where we just plugged in numbers, because they tell us hyperbolic tangent of x equals 12/13. And they ask us to just find the other hyperbolic functions. Well, cotangent hyperbolic is just going to be 13/12, so we don't even need to write that. But what about the others? I know that 1 minus, I believe it's hyperbolic tangent squared equals hyperbolic secant squared. We learned that identity in the explainer video somewhere. The links are in the description. So we could write 1 minus 144 over 169 equals hyperbolic secant squared. And that means hyperbolic secant squared is going to equal 25 over 169. So take the square root. I'm going to get 5 over 13. Yeah? Now, what's secant hyperbolic or hyperbolic secant? Is that not the upside down version of hyperbolic cosine? So can I immediately say hyperbolic cosine equals 13/5? Feels like that's true. We also know that hyperbolic tangent, which we're told is 12 over 13, is also equal to hyperbolic sine over hyperbolic cosine. So that if we multiply these up, we would get 12 hyperbolic cosine equals 13 hyperbolic sine. Of course, this is all of x. I'm just shorthanding it a little bit here. You should be able to follow this. So that would be 12 times 13/5 equals 13 hyperbolic sine. Of course, the 13's cross out, so it would be 12/5 for hyperbolic sine. That should cover most of the functions for this one. What about the rest? Can we do the same rule? Can you find this out with me? Let's figure it out. If hyperbolic cosine of x equals 5/3 and x is greater than 0, find the values of the other hyperbolic functions at x. I think the trick to this one is going to be to use the other identity we figured out, which is that hyperbolic cosine squared minus hyperbolic sine squared, I'll even write of x, equals 1. So 5/3 squared is going to be 25 over 9 minus hyperbolic sine squared equals 1. Obviously, we want to subtract that out. So what's 25 minus 9? Negative hyperbolic sine of x squared equals 9 minus 25. Well, what's 25 minus 9? That's 16, so we're going to get negative 16/9. And we'll cross off the negatives here, and we'll take the square root, so we don't get the square root of a negative. So we'll get the hyperbolic sine. It's going to equal 4/3. That makes sense to me. So we can go from there, because hyperbolic tangent of x is going to equal sine, hyperbolic sine, which is 4/3. God, that's ugly. Let's fix it real fast. 4/3 divided by, they gave us hyperbolic cosine of 5/3, and we could divide, but I'll multiply by the reciprocal instead. We'll cross that out, and you're going to get 4/5 for hyperbolic tangent. And cotangent's hyperbolic should be obvious. It's going to be the upside down version, 5/4. You can just go from there. Secant, right? Hyperbolic secant is 1 over hyperbolic cosine, just like everywhere else. So that's just going to be an upside down version, is 3/5. And what didn't I touch? Cosecant? Okay. Hyperbolic cosecant, if you ever need that for some unknown reason, is going to be the upside down version of hyperbolic sine. So it'll be 3/4. And that's it. So the trick to doing these questions and finding the other identities here is just to know your two trig identities for hyperbolics.